Assalamualaikum and good day to the judge and audience. My name Kaidi Bumbu Zakaria, co-inventor in our team. Firstly, I want to thank to the University Malaysia Pahang because give opportunity to us to share our research in this CTRAD 2022 competition. This is our poster. Our research title is Performance Evaluation of Pressurized Water Scrubbing Process for Biogas Purification using Aspen Plus software. Our inventor is TS Dr. Nolisa binti Harun, I Kaidi bin Zakaria, and my friend Syazwan bin Abdul Hamid is co-inventors in our team. We'll continue our presentation by presenting our research.
Our work title is Performance Evaluation of Pressurized Water Scrubbing Process for Biogas Purification using Aspen Plus. For the introduction, biomethane is a biogas in which carbon dioxide, hydrogen sulfide, and water have been removed. Biogas is a renewable energy source that can be used to substitute fossil fuel in power and heat generation. Biogas is produced by anaerobic digestion process. Anaerobic digestion is a process by which organic matter such as animal or food waste broken down to produce biogas. Biogas need to be cleaned first before being used for fuel, heat, and electricity. There are several processes to purify biogas such as pressurized water scrubbing, pressure swing adsorption, physical adsorption, chemical adsorption, membrane separation, and cryogenic separation. According to the figure, water scrubbing is the most common process that had been used to purify biogas. This is because it is easy, low cost, and low toxicity rather than other processes. For the problem statement, the main problem is a high water demand. This is because water is recycled continuously, so evaporated water must be replaced. In order to increase the adsorption ability in the column, high water demand is required. For the main objective is to integrate the pressurized water scrubbing with anaerobic digestion process for biomethane production from food waste. For the scope of study, firstly, model development of pressurized water scrubbing for biomethane production using Aspen Plus software. Second, integrate pressurized water scrubbing with anaerobic digestion process to complete the biomethane production from food waste. Third, perform a sensitivity analysis to maximize biogas production from food waste performance by varies the hydraulic retention time, temperature, food waste composition, water flow rate, adsorbent column pressure, and flash column pressure.
I will present about our study methodology. First, the thermodynamic model for water scrubbing process selection. In this study, the NRTI, non-random to liquid, which either gas and Henry Law model was chosen for the water scrubbing process. Next, column selection for water scrubbing process. Refract without reboiler and distillation was selected as absorber column. Refract with reboiler was selected as stripper column, and flash was selected as flash tool column. Next, specific process condition and column specification. For the calculation type, for the absorber, rate-based calculation type was used, whereas the equilibrium calculation type was used for the stripper. The absorber column has 18 stages, whereas the stripper has 7 stages. The absorber column will operate at 10 bar pressure and at 20 to 34 degrees C. For the stripper column will operate at 1 bar and 100 degrees C, and flash column will operate at 1 bar and 25 degrees C. In absorber column, the stage will fillet with metal reaching packing that have dimension 15 mm. Next, an integrate model of anaerobic digestion and pressurized water scrubbing process flowsheet. This is an anaerobic digestion region and this is pressurized water scrubbing region. Process description for integrate flowsheet. First, the food waste and water will enter the process at ratio 10 to the 1. The food waste and water mix in the stoichiometry reactor to undergo hydrolysis and continuous degradation reaction in CSTR to produce biogas. Biogas from CSTR enter the flash 1 to remove some water. After some water was removed from biogas, the biogas entered the purification process. The biogas went to the absorber under a pressure of 10 bar. Pressurized water was used in the absorber to dissolve CO2 from the biogas. Biomethane will come out at the top of absorber as product. Next, the biogas removed from the absorber will recycle back at flash 2 to reduce biomethane loss, and the separation water from flash 2 into the stripper column to undergo the desorption process and recycle water to the absorber and release free CO2 gas to the atmosphere. Next, the result from this simulation is valid with European standard composition for biomethane. Next, sensitivity analysis. Sensitivity analysis is carried by study the effect of hydraulic retention time, the effect of temperature, the impact of absorber column pressure, the impact of food waste composition, the effect of water flow rate, and the effect of flash column pressure on biomethane production. Next, we go to the result of the simulation. From 70,000 kg of waste mixed with 7,000 kg of water can produce 9,595 kg per day biogas that has 64% methane and 30% carbon dioxide by volume. The biogas enter the purification process to produce 3,467 kg per day biomethane, which purities 98% by percentage methane. The biomethane in this simulation have 98.3% of methane and 0.04% of carbon dioxide by volume. Next, comparison of biomethane in this study with literature. In this study, the methane has highest volume than the literature and has lowest carbon dioxide volume percentage than literature. After that, methane recovery. To maximize the biomethane process, the methane that been scrubbed in the absorber column will recovery back at flash column. 2,796 kg per day methane from the absorber column into the flash column. The flash column will recover 2,551 kg per day methane and 354 kg per day methane was wasted. Next, water recovery. To reduce the water usage in pressurized water scrubbing process, the water was recovered at stripper column. 134,475 kg per day water from the absorber column will enter the stripper column. The stripper column recovered 133,321 kg per day water and 1,154 kg water was evaporated and released to the atmosphere.
The first sensitivity analysis is to study the effect of hydraulic retention time on biomethane production. Hydraulic retention time is varies from 15 to 30 days. According to the graph, methane mass flow increase as HRT increase. This is because microorganism has much time to actively degrade the material. The next sensitivity analysis is to study the effect of temperature on biomethane mole fraction. Temperature of CSTR reactor is raised from 55 to 100 degrees Celsius. According to the figure, biomethane mole fraction is decreased as the temperature increase. So, the optimum temperature that can achieve high quality of biomethane is at 50 to 60 degrees Celsius. The next sensitivity analysis is to study the effect of food waste composition on methane production. Carbohydrate composition is varies from 50 to 55%. Fat composition is raised from 40 to 50%. Both of the figures show the increase of methane mass flow. This is because carbohydrate and fats will supply additional energy to microorganisms, so this will increase the methane production.
Next, effect of absorber column pressure on biomethane composition. Absorber column pressure was varies from 5 bar to 11 bar. The results show the percentage composition of methane increase when the pressure increase. The result also show the solubility of CO2 is increased when the pressure of absorber increase. The increase of solubility of CO2 is because the increase of absorber column will increase the interaction between absorber and absorbent. Next, effect of water flow rate on biomethane composition. The water flow rate was varied from 9,500 kg per day to 19,500 kg per day. The results show the CO2 composition decreased and the methane composition increased significantly when more than 9,500 kg per day water entered the flow rate process flow. The decrease of CO2 composition is because the absorption of CO2 in water is increased when the water flow rate is increased. High liquid volume supplied will provide the high amount of adsorbate and high area for absorption process occur. Next, effect of flash column pressure on biomethane composition. Flash column pressure will vary from 1 to 5 bar. The results show the increase of pressure will reduce the methane composition and CO2 composition. It is because the amount of biogas being recovered is decreased when the flash column pressure increases. Next, economic analysis. The economic analysis for this simulation also was carried in the Aspen Plus software. Total capital cost to build this biomethane plant is 5,970,218 USD. To operate this biomethane plant, 2,106,118 USD per year was needed.
As a conclusion, the integrated anaerobic digestion and pressurized water scrubbing process was developed. This study produced a 3,467 kg per day of biomethane. This study also produced 88% of biomethane purity and 99.7% of carbon dioxide removal. So, this study is meet the criteria of biogas upgrading. For the recommendation, conducting a laboratory experiment on local food waste for the model validation and optimize the operating condition to minimize the capital and operating cost. That's all from us. Thank you.